The method 6 beta for monitoring rate of reaction is based on change in volume. Change in volume. So beta, we have variety of devices which can measure change in volume. Change in volume. So that change in volume is monitored from change in number of moles. Okay. Change in volume can be monitored from change in number of moles in balanced chemical equation. Change in number of moles in balanced equation. And we have variety of devices. Those devices are not supposed to learn in A level. So we have devices which can measure volume change of gas as well as volume change of liquids. So for example, if you have this reaction N2O4 gas and it goes to 2NO gas. So 2NO2 gas. So what is happening here? How many moles we have on the left hand side? 1 mole. How many more moles we have on the right hand side? 2 moles. So we can clearly see that the moles are increasing. It means volume will increase in different times interval. So moles are increasing, which obviously means volume is increasing. So volume will increase in different time intervals, will increase in different time intervals. So with this beta, different time intervals. So we can make a volume time graph. Okay. So with this
Yes.
data, volume time graph can be plotted. Graph can be plotted. And that volume time graph पे जो gradient will be rate. Gradient on that graph is rate. Got the idea?
Yes, sir.
Acha. We can take any other reaction as well, in which, for example, if I say in which the the moles of the aqueous thing are involved. For example, if you take HCl aqueous and ammonia aqueous, and it produces ammonium chloride, which is also aqueous. So again, we see beta here that we have 1 mole on the right hand side and we have 2 moles on left hand side. So once again, you can clearly see that the volume is changing because moles are changing. Mole change correspond to volume change. So volume change because moles are changing. Moles are changing. So we have devices which measure this volume change. And then we can make volume time graph. Okay. So this
Yes.
was the sixth method for which was based on volume change. Now, beta, the seventh and the last method is titration method. So we perform titration in this beta method, titration method. And we need to know that what this method is and when we will apply this method. They will give us the reaction. For example, given reaction is this one. This is chloromethane plus OH negative, and this goes to alcohol plus chloride. So this is the given reaction, okay? So beta, one of the reagents should be in excess because after two reactants, we will like to monitor one reactant. We can monitor one reactant at a time. So let us say this reactant OH wala is limiting. So the other reactant we have to take in excess. And remember one thing that the excess reactant does not affect rate. Excess reactant does not affect rate. Okay. Now, what is better done that we will take a container. Okay. In this container, we will mix the two reactants, this chloromethane and OH. The two reactants are mixed. As soon as we mix the reactants, we will start the stopwatch. We will start stopwatch. Okay. And then beta examiner will give you the idea that what other thing is given. So suppose the other thing is given in a burette is known concentration of HCl. So you have known concentration of HCl here in this burette. Okay. And you have start the stopwatch beta. So and indicator is also given. So what beta, what comes in your mind that how can you monitor the concentration of OH ions? What you would do to know the concentration of OH ions in this container?
The volume that is needed for the reaction to stop.
Beta, we will take some volume from here. Okay. That volume is our choice that how much volume we want to take. So suppose I'm taking 25 cm cube. Otherwise, I could have taken any other volume. Okay. So let us say I took 25 cm cube from the main reaction is happening here in this container. So I just took this 25 cm cube volume. Let's say after 5 minutes. Okay. Let's say after 5 minutes or after 2 minutes or after 3 minutes, I took this volume. So obviously this volume has OH ions in it. And then I will add indicator and then I will titrate. So after titrate, would I be able to know the concentration of this OH ions beta?
जी sir.
Titration will help me and I will apply stoichiometric data and I will calculate the OH ion concentration in after 5 minutes. You got the idea?
Yes
So
sir.
then beta, I have to repeat this experiment after different time intervals. Let's say after 10 minutes then. After 10 minutes, I will once again take the same volume which I took for the first time. So I will take the same volume as 25 cm cube. This has OH ions as well. And now I will arrange a burette here. In burette, the same HCl with the same concentration is present. And I will add indicator, will titrate again. So when after addition of this indicator, I will titrate again. So again, I will get a value of OH ion concentration. Got it?
जी sir.
So beta, what you think, which OH ion concentration will be greater, this first one or the second one?
The second one?
The second one, OH will be greater, beta?
Oh no, be less.
The second one will be lesser and the first one will be greater. So beta, then I will repeat this experiment in different time intervals. Repeat the experiment in different time intervals. Time intervals. And what I will get better when I repeat the experiment in different intervals, I can plot concentration time graph and gradient on that graph is rate. Gradient is rate. Any confusion better?
No.
Okay. So better, there's one more point which you need to keep in mind. Each time when I take, let's say, 25 cm cube, I took here in this conical flask, I will add ice in this conical flask so that the reaction is quenched. Quench means reaction is stopped. So to stop the reaction in conical flask, like in the main beaker, the reaction is carried on. But I would like that the reaction between OH and CH3Cl is stopped here because I have fixed the time. Look, I said the time is 5 minutes. Then the OH should not react with CH3Cl. For that, I will add ice to stop the reaction between halogenoalkane and OH. Between any confusion here?
No sir.
But this ice will not stop acid-base reaction because acid-base reaction happens at low temperature as well. So each time when we take a sample in conical flask, we have to add ice, and ice quenches the reaction. Quenches means stops the reaction. Quenches or stops the reaction. So, but this is the method which is titrated